European Association for Activity-Based Modeling, or EAABM for short. Our mission is to foster activity-based modeling in Europe. And in this webinar series, we are looking at Sorry, there was a microactive. We're looking at existing activity-based models, and not only what they do, but also how they were built. And with this inside view, we hope to demonstrate that today ABMs can be built within reasonable time and effort and are no longer a risky proposition. The two models that we are exploring today come from the United States and from Switzerland. It's my great pleasure to welcome SANDAG, the Metropolitan Planning Organization for San Diego, California, and UrbanEcho from Switzerland, as well as the developers behind the modeling software used. And this time, interestingly, there are two open source packages, ActivitySim and Eqasim. For each of the two models, we will first hear a presentation by the end users and by the software developers, and then there will be ample time for questions. Before we get going, please put your questions into the chat so we can sort them a little bit ahead of time. Mute yourself if not already, and note that this webinar will be recorded. And without further ado, let's start with the first model, SANDAG and ActivitySim. The floor is yours.
Thank you, Klaus. Let me share my presentation. Can everyone see my slide deck?
Yes.
Okay, great. Thank you. Thanks everyone for giving us the opportunity to present to you today on the SANDAG ActivitySim model. I'd like to acknowledge my co-presenters, Bhargava Asana from San Diego Association of Governments and Joe Castiglione from Zephyr, both of whom you will hear from shortly. Let's see, advance the slides here. So in today's presentation, we're going to do a brief introduction to SANDAG. I'll cover the core ActivitySim model and then speak a bit about how we've customized the model for SANDAG's needs, covering micromobility, electric vehicles, and special market models. And then I'll hand it back to Bhargava, who will talk about SANDAG model applications. And finally, Joe will conclude with some remarks about the ActivitySim consortium. Bhargav?
Thank you, Joel. Hello, everyone. I'm Bhargav Sana. I lead the transportation model development team here at SANDAG. SANDAG is the regional planning agency for the San Diego region. It's responsible for developing long-range transportation plans. It serves as this agency called the Metropolitan Planning Organization, or MPO. And it's also responsible for coordinating transportation investments across all the 18 jurisdictions or 18 cities and the unincorporated area of San Diego County. We also have several tribal governments in the region that we have on the board. The region has over 3.3 million residents and is quite diverse. It has coastal communities, dense urban cores, suburban corridors, and also rural areas that are in the outer parts of the county. Additionally, we have complex travel markets. You might have noticed in the south, there's an international border with Mexico, and every day, more than 100,000 people cross the border into San Diego for work, school, shopping, etc. The region is served by two airports. One is San Diego International Airport, and the other one is across the border, Tijuana International, that can be accessed through a cross-border terminal. Overnight visitors constitute a significant portion of the travel demand. There are many tourists and business travelers all year round. Finally, there's goods movement and commercial vehicle trips to account for. So why did we adopt activity-based modeling? In one sentence, it is to capture the rich behavioral complexity of all these travelers. In addition to mode choice, we want to better capture or represent time of day decisions, intra-household coordination, and trip chaining. ABM enables us to evaluate equity impacts of many of the pricing policies for parking, managed lanes, and transit, etc. Developing and maintaining an ABM, as many of you might know, requires adequate resources and funding, which I think we were fortunate enough to get. We first developed an ABM using the CT ramp framework way back in 2013 and have been using ABMs for regional transportation plans ever since. It is now an essential tool to demonstrate that we are meeting state and federal emission requirements through our transportation plans. Most recently, we transitioned to a new ABM built using the ActivitySim platform, and I'll hand it back to Joel to go into some of the details of that.
Okay, thanks, Bhargav. So I'm going to start with an overview of what ActivitySim is, what it looks like, and how it integrates with travel models. This slide shows a graphical representation of ActivitySim with typical model inputs, zone data, transportation level service skims, and synthetic population. The population synthesizer that was initially developed for Oregon Department of Transportation has been adopted by the ActivitySim consortium, and it's also in Python, and I think there are some applications of it in Europe as well. It's population sim. And in the middle of the slide is a representation of the flow of ActivitySim model components. We start by building some accessibilities. Then we move into household and person mobility models. Then we generate activities and tours. We schedule them. We choose a location for them and a mode for them, and a number of stops for tours. And one unique aspect of this that was borrowed from the CT ramp model is that activities are coordinated across household members. And then there are trip level models that predict stops on tours and their destination and schedule the tour, and ultimately write trip matrices that can be assigned to transport networks. ActivitySim does not include a assignment software component, so it's interacting or interfacing with commercial transportation software packages. It's relatively easy to download and install ActivitySim. There's a GitHub site with clear instructions on how to do that and how to integrate it with your model. Typically, the way we do this is start with a donor model. So we borrow a model from an existing model from another region, and we implement it for a new region and modify it. And so please do look at the website for instructions on how to do that. ActivitySim is implemented in a series of text files, YAML files, which are sort of like control files that tell the model system how to work and what data to read. And we use comma separated value files for utility specifications. It relies on a pipeline for running models in order, which is stored in a YAML file. It's relatively easy to insert or drop models from that pipeline. It's written in Python, and it utilizes NumPy and Pandas syntax for specifying models and processing data and so on. There are pre and post processors files that are, or components that are run before and after each model component that are used to prepare variables or process results for the next model. And coefficients are typically stored in separate files. As I mentioned, we usually start from a donor model and then modify the various aspects of ActivitySim to work with the local inputs, such as like unique household and person variables, unique land use variables, employment types, and so on, and unique transport level service schemes. So everything is highly configurable. On the other hand, you could also implement the same variables for your region as were used in the donor model. So there's a couple of options on how to go there. The configuration varies between regions. These are some of the more commonly configured attributes of the model. The spatial resolution is configurable, so you can have a TAZ level model, or what we call a one zone model, or you can implement a microzone system, which is a smaller spatial unit that's used for more accurate walk and bike times and costs. You can modify the time period resolution. There are models with 1 hour resolution and 30-minute resolution. It is possible to modify it to even a smaller resolution, although that could affect runtime. Changing the mode detail in the mode choice models is pretty common. I'm going to talk about that in a bit. And adding or dropping mobility models is also common, depending on policy sensitivities and needs in the region. ActivitySim does have built-in model estimation functionality. So it's common to get the model running with a synthetic population, and then once it's running, replace the synthetic population with data from a household survey and run that household survey through the software with the observed choices for each component, which can then be used to build estimation data bundles for each model component. There's an integration with Jupyter Notebooks that allows you to estimate models using those data bundles and write out the revised model specification and model coefficients from that estimation, which can then be read into the next run of ActivitySim. So everything is integrated, and you don't need different additional estimation software to estimate model components. Okay, so now I'm going to switch gears and talk about how we customize the model in a few ways for SANDAG. There isn't enough time to talk about all of the things we did, so this is just going to sort of give you a taste of how we configured the model for this particular application in a few cases. One thing that SANDAG is particularly interested in is micromobility, e-bikes and e-scooters. So there are a number of publicly available e-bike and e-scooter systems available in San Diego County. They're pretty heavily utilized. There's a small share of households that own e-bikes, but that is increasing steadily and projected to increase significantly. And so the impacts of the ownership of e-bikes and e-scooters and availability on VMT and transit access and so on is of a lot of interest. So to modify the mode choice model, we added a micromobility nest, and we defined 2 new modes. We model private ownership of e-bikes and e-scooters, as well as publicly available e-bikes and e-scooters in the model. So this is just an example of how mechanically we implemented e-bikes and e-scooters in the model. There's a file that has global constants in it, to which we added constants like speed, cost, and time to rent for micromobility modes. Those were added. They're actually, I think we've expanded it to have separate settings for e-bikes and e-scooters. We specified the rental access time and availability in the land use data file based on information that we had on where the shared e-bikes and e-scooters are located, typically in more urban parts of the county. We added the micromobility nest to the nesting structure in the mode choice control files and specified the mode choice utility equations and variables in the preprocessors and the mode choice specifications. And so this is just the table below shows just a snippet of calculations for e-bike and e-scooter utility components in vehicle time, access time, and cost. We assume that if somebody owns an e-bike or e-scooter, the access time is 0 and there's no cost. And if somebody does not own one, then they would have to use publicly available micromobility. So that's micromobility. Now I'll talk a little bit about adding electric vehicles to the model and tailoring it to SANDAG's needs. The consortium, ActivitySim consortium that Joe will be talking about in a bit, authorized or funded an effort to develop a vehicle type choice model. The vehicle type choice model produces information on greenhouse gas emissions, energy consumption, and vehicle value and expenditures, and essentially generates a household level vehicle file for every vehicle owned by every household in the region. And the model's capable of addressing a number of policy questions that were particularly important to SANDAG, such as how might the vehicle fleet change if we build more public EV charging stations? How would energy consumption and greenhouse gas emissions change if we move to a more fuel-efficient fleet? And an extension of the model was created for SANDAG to explicitly model autonomous vehicles, and there's lots of questions about how that would how they would affect mode share and vehicle miles of travel. This slide shows the alternatives file for the vehicle type choice model. It lists for every combination of body type, fuel type, and age, a number of attributes that are used in the model to predict which types of vehicles households own, including number of makes and models, miles per gallon of each vehicle, range, the price of buying a new vehicle of that type, and the auto operating cost. And that information for the base year was all gleaned from publicly available data. But the key here is that we're forecasting this into the future, so we need to extend that alternatives file out into the future and enumerate alternatives that describe what options will be available. And so there's some forecasting of the alternatives file that's needed. We developed some tools to more easily do that so that you don't have to specify, each row of this pretty big table individually. But basically what we're doing for SANDAG is taking their projections provided by planners and translating that into information on vehicle availability in the future that the model can react to. And as you can see here, there's an AV modifier on some of these vehicles, assuming that would be, available in the future for certain models. Okay, so that's electric vehicles. Now I'll pivot and talk quickly about special market models. There are a number of unique travel markets in San Diego, as Bhargava mentioned. There's cross-border travel, which is pretty significant, and there's a lot of residents of Mexico who commute into San Diego County, travel within the county, and then return to Mexico by the end of the day. We wanted to capture that travel on within the region, and also allow SANDAG to test some sensitivities around, or policies around, new border crossings. There's significant tourist and business travel to the region, so we built an overnight visitor model. There are 2 airports, as Bhargav mentioned, so each airport has an air passenger ground access model. There's a lot of interest in how passengers would access San Diego International Airport, and a big project to look at mobility hub serving that airport. So all of these are handled with special market models built in the ActivitySim framework. I'm going to focus really quickly on the cross-border travel model because it is of a lot of importance to San Diego and interesting to talk about. There are currently 3 U.S.-Mexico border crossings in San Diego County. There's the biggest one is at San Isidro, which is Interstate 5. It has almost 100,000 crossings per day. There's one to the east of that at Otay Mesa that's served by a toll road that has about 40,000 crossings a day in 2019. And there's a very small border crossing at Tecate, which is even further to the east with about 7,000 crossings. One thing, interesting things about these crossings is they all provide pedestrian access, which is then typically served by transit on the US side of the border. And the pedestrian mode accounts for about 1/3 of all the crossings, so not insignificant share. In fact, the trolley stop just north of the San Isidro border crossing is the highest ridership stop in San Diego County. There are also special lanes for expedited entry for pre-qualified travelers. This is a graphical depiction of the cross-border model. It's a tour-based model as opposed to an activity-based model. It takes all of the standard data that was described in the previous slide and builds essentially a border crossing synthetic population, and then models their travel into the county, which point of entry they choose. Tours are generated. They're assigned a primary destination in San Diego County, and then there are stops and trips generated within San Diego County. One of the enhancements we made to that model was a dynamic wait time model that takes into account the number of border crossings and infrastructure at each point of entry. And all this was implemented in ActivitySim, and models were estimated using the built-in estimation functionality from a travel survey that was collected in 2019. Some of the key questions the model can answer: what would be the reduction in wait time if additional lanes are made available? What's the demand for a new border crossing that SANDAG is currently SANDAG and partner agencies are currently constructing? And how would changes in the transport system, such as LRT extensions, light rail transit extensions, affect ridership? So that was a bit of a whirlwind, so I apologize for that, but limited time. With that, I think I'll hand it back to SANDAG. We'll talk about using the model in production.
Thank you, Joel. I'll be quick. There's just a few more slides. After calibration and validation of the 2022 base year with this model, we ran a whole series of sensitivity tests. We tested a broad range of policy levers, including the regular transit headways, land use changes, auto operating costs, e-bike ownership levels, parking price impacts, etc. During this, we found some bugs. We went back, fixed them, and ran these again. And this exercise built more confidence that the model was ready for application. Next slide, please. We also built a cloud-based pipeline that automates reporting and data management. All outputs are written after the model is run. All outputs are written to an Azure data lake. And we leveraged the Databricks platform to collaboratively develop notebooks to derive further summaries and performance metrics. Next slide, please. And all this processing then feeds into several interactive Power BI dashboards that we have used to easily share model results across the whole agency. Currently, we are relying on ArcGIS for most of our mapping needs, but very recently we've started using SimWrapper, which some of you may be aware of, was developed at TU Berlin. So we've just started using that. Okay, next slide, please. So what are we doing currently? We've finished applying the model to our 2025 regional plan. And it's going to the board for adoption this Friday. So that's how close we are to getting a validated plan using our latest model. Everybody's pretty nervous here at SANDAG. After that, we're going to use it for a variety of applications, some of which Joel was talking about. We have a huge project to improve regional transit connections to the San Diego International Airport. So there's several bus and light rail alternatives we are going to evaluate with this. We are testing toll removal of a tollway that is in the southern part of the county, and the electeds want to analyze toll removal and making it general purpose. There's also some managed lane conversion projects that need to be evaluated, and all of these have major operational and equity implications. Across all these scenarios, our performance metrics focus on the big regional priorities. We want equitable outcomes. We want reductions in vehicle miles traveled, and also improve greenhouse gas emissions and air quality. That's all I have. I'll now turn it to Joe to talk about the ActivitySim consortium.
Thanks, Bhargav, and thanks, Joel. So as both Joel and Bhargav described, the platform that SANDAG has been using has been the ActivitySim platform for a lot of this work. And the ActivitySim project was started about 10 years ago, maybe a little bit more, by 3 agencies. And their motivation for doing so was because having each one of those agencies individually develop their activity-based modeling, software platform was pretty expensive, and it was expensive in no small part because each one was doing it individually, even when they were notionally using the same platform. Everything needed to be, or many things needed to be, developed on a bespoke, basis. And what that meant was that when improvements were made, whether they were to the software performance or methodological improvements, it was hard, and they couldn't really easily be kind of shared. So the solution was to come up with a collaborative software development or software kind of platform, and to do that together, to make it all open source. And the way that it was funded was through a pooled fund. So each one of those initial agencies was pitched in $35,000. That was used to then procure consultant services. And develop the software. What was really also important about it is it's all a shared kind of decision-making process. So the agencies themselves collaboratively decide what the investments are going to be, what the priorities are, and then contract out with consultancies to do that development work. If we could move on to the next slide. Since its initial, or I should say some of the core principles, number one, as I mentioned before, that it's collaborative. It's a common platform, and that we're all kind of working off the same platform. It's also collaborative in the sense that the decision-making, as I said a moment ago, is all done jointly by those agencies through kind of a consensus-based approach. It's much more cost-effective than trying to do model development individually. I can say from my own experience, I think it's not uncommon for the total cost of developing an activity-based model under the kind of previous context to easily exceed or $1 million US. In contrast, 10 years of investment in this software platform might just be a few $100,000. So it's really significantly more cost effective than trying to do this on your own. One of the goals was also to make it, kind of practical and easy to use. We don't want to make it so complex that it's a barrier to entry. So as the project has evolved, we've really been striving to make sure that it's well documented, make sure that it's easy to install, make sure that it's highly configurable. But also new things emerge, new challenges. Like just for example, Joel referred to the fact that the fleet composition has become increasingly important as propulsion technologies have evolved. Or in addition, things like the radical changes in telecommuting. And so the way that it's designed is really to be able to accommodate these sorts of behavioral changes. And of course, we're always concerned about performance. People cannot wait forever for a model run to be done. And so we're consistently year over year making investments to improve that performance. In the time it started, about, as I said, 10 years ago with just 3 agencies, there's now about 14 or 15 participating agencies, 11 within the US, but then also a couple state departments down in Australia, as well as Vancouver up in BC. You can see the list of all of the cities that are included, cities and regions that are included on the left. And again, it's a great and significant number of major cities here in the US. And then for the final slide, we're always interested in having other folks that are interested in joining, other agencies joining, and even international agencies. If this is something that might interest you, you should reach out to us at the email you can see down below, the admin@activitysim.org. It's not uncommon for interested parties to listen in on our meetings. We meet very frequently, about twice a week, and we do that, pretty much across the whole year, and that's an opportunity. And in fact, one of the great advantages of the project is not just that it produces a product of actual, functioning open source performance software, but there's a community of people. We frequently have 20 to 30 people on every one of these meetings, a mix of consultants and other agency staff. They're collectively describing the challenges that they're having, the investments they'd like to make, and solving problems together. So it's not just a software solution, it's also a community. That is my final slide. thank you all for being here. And thanks especially to Joel and Bhargav for all of their amazing work.
Thank all of you for this extremely rich and insightful presentation. Thanks. And I can see that we have already a chat full of questions that we can go through now. Let's start with Jean-Baptiste from PTV. Can you tell us something about the runtime of the model and which KPIs have been used to assess the calibration? Two very different questions.
I guess, Bhargav, would you like me to address or?
Sure. Could we also put up that slide because there's other questions about hardware requirements. We had this slide that we didn't quite cover. We had it as backup. We knew some questions might come up about
Yes, I have to find it.
Oh, okay. It's at the very end of the slide deck.
Okay.
Just
here we go. I need to.
Oh,
sorry, I have to bring the slide deck back up here. Here we go. Can you see it?
Yes.
Yes.
And
oops. There we go. I'll just leave it here.
Great. Thank you so much, Joel. Yeah, the total runtime is about 37 to 40 hours based on how far into the future the horizon year we have is 2050. It has 3 global iterations in terms of TAZs. We have about 5,000 and microzones 24,000. Hardware requirements were also asked. So I have some information there. The peak RAM required is close to 1 terabyte, so it's not low. And currently we are working on improving that along with the development that's happening in ActivitySim consortium. But briefly, maybe the KPIs to assess I'll let Joel talk a little bit about that. He's done most of the work.
Thanks. Yeah, just a note on runtime. The SANDAG model is probably in the upper end of the ActivitySim runtimes, due in part to all the special market models, which are additional model components that are run at every iteration. I would say the runtime, like for example, the Metropolitan Washington Council of Governments, which covers the DC area and is a bigger population, but is a TAZ level model as opposed to a microzone level model, runs in about 15 hours with 3 iterations. So that gives you a sense of the range of run times. I think, in terms of calibration metrics, all the standard calibration metrics you would expect, on trip length or location choice, tour length, frequency distributions, average trip lengths, trips and tours by mode, share, time of day, and so on. We actually, there's a number of calibration dashboards that have been built for ActivitySim by various agencies and consulting firms. I think SANDAG, we've used at least 2 of them. One's in Power BI, another one's in R. And so the idea behind them is every time you run the model, you get a full comparison on every model component between that component and the survey, which is looked at and used to judge whether the model is sufficiently calibrated. And of course, on the assignment side, traffic counts and transit boardings are all looked at. Standard things that you would look at for a trip-based model. Yes.
Okay. I see several questions dealing with alternative or different models for San Diego to deal with the migration from the CT ramp model. I mean, the ActivitySim model is already your 2nd generation activity-based model, as we heard. And one question asks, why did you move? And the second question asks, where did you start from? Did you use your own 1st generation model as the donor for this migration and migrate it from one platform to the other, or did you choose an ActivitySim model for a different region as the donor, as you do when you start from scratch typically? And which would you recommend? Okay.
I can quickly do the why did you move, because Joe actually covered a bunch of reasons why it made sense to join the ActivitySim consortium. We wanted to join forces with the other MPOs and public agencies. That'll relieve a little bit of pressure on the funds that are required to maintain and keep further developing an activity-based model. We had also, I think, taken CT ramp as far as we were able to. It was all built in, developed using Java, and that was not exactly the strength of many of the transportation modelers and data scientists that were at SANDAG. So that's another reason where all of the ActivitySim platform is built using Python. So it's been great, but I'll let maybe Joel take a little bit on what exactly we did with respect to, donor conversion, all of that.
Yeah, we started for SANDAG, we started from the Southeast Michigan Council of Governments model, which covers the Detroit, Michigan region, because the design specifications for SANDAG were similar to the pre-existing model. And then, as I mentioned, heavily modified it to the design that was envisioned for SANDAG. For the special market models, we sort of had to start from scratch. So we spent considerable time building out those models in the ActivitySim framework, which then in some cases causes staff to modify some fairly low-level code in ActivitySim, and those changes were eventually all adopted into the ActivitySim code base by the consortium so that it should be easier next time.
Okay. I have two questions about micro and macro mobility. The micro mobility question is, how do you include the supply effects of micromobility, especially the access time that depends on the density of available bikes or scooters, unlike other models which include the execution of the plans in an agent-based model, where you can derive those probabilities of finding a scooter or a bike nearby can be derived from the simulation. You run separately from the assignment. So how do you approximate these effects?
If I understand, the question is whether how do we take into account the time that it takes to get to a potential
yes,
micromobility share site?
Yeah.
So we take a rather simple approach, which is that we rely on planner estimates and observed data in the base year and planner estimates in the future to specify access times. And so we provide those access times in the microzone input file. And they range from just a couple of minutes to unavailable, essentially. So if you're like in a rural part of the county where we don't expect there to be any e-bikes or e-scooters publicly available, then the mode is simply not available unless you own one. Mm-hmm. And if you're in a more urban part of the county, like downtown San Diego or one of the beach communities where they're prevalent, then the access time is very short.
Okay. And the other question is on the macroscopic side. Do you sometimes find the need for answering questions in a shorter runtime, for example, and therefore keep a macroscopic model in addition to your ABM model, or do you use the ABM model for all your planning needs?
We've been using the ABM model for all our planning needs.
Okay.
I think we've been experimenting with a few other models, like there's the Vision Eval model, but we haven't quite brought anything to production level yet.
No. Sometimes we hear from NPOs that run a dual approach, a hybrid approach with a macroscopic model for, let's say, quick response modeling, and then the ABM for the deep dive into the most promising options. So that's where the question comes from. I think we still have time. Very good. What about future year modeling? We heard already that you had to extend some of the base data into the future for the electric vehicle fleet, for example. How in general do you cope with future year modeling, especially when it comes to the synthetic population? Do you age your synthetic population, or do you generate new synthetic populations independently for future years? What's the approach?
Yeah, we don't have a system to age the population. I think I believe those are called population evolution models. There are some that are being developed in research settings, but we haven't tried those yet. And so we have a macro level forecast for the whole region in terms of population and employment. We are looking at the distribution of incomes, age, all of that is coming from an economic model called REMI, I think, and it's once we get it at the regional level, it's taking into account fertility rates, mortality rates, immigration into the region and immigration out of the region. So it's doing taking some of these high-level parameters and coming up with regional forecasts. Once we have the regional level numbers for all of these horizon years, we divide it into the sub-region based on the plans of the individual jurisdictions. And so there's a land use team that's focused on that and then gives us all of these controls that we have available for all of the future years, 2030, 35, 40, 50. And then we run that through PopulationSim to generate synthetic populations for each of those years and plug them into our ABM.
Okay. I guess this also takes care of the second question about future year modeling. The question about the associated assignment module was already answered in the chat. So the short answer, ME, is the assignment package. Then there is a question for Joe, I suppose, because one attendee asks, what are the requirements for joining the consortium meetings on ActivitySim or Zephyr, whatever you prefer? Are there other European agencies partaking in these, and what if they wanted?
Right. So in terms of participating in a meeting just to get a flavor for how the consortium does its business, you should just reach out and we can arrange that. People who are prospectively interested in joining can certainly listen in on meetings. We do limit meeting participation, though, and the decision making to to agencies that have actually joined the consortium. So the requirements are simply that you're a public agency. It doesn't have to be in the US. As I mentioned, we have agencies participating in Canada and in Australia, and that you contribute that annual contribution. And it's done on a one-year basis, typically. Membership in the consortium, if people want to, or agencies want to do it for longer than that, they're welcome to, but it's an annual participation membership.
Okay, thanks. And I still found another technical question. And it's on post-processing the results. Has the SANDAG model been used to calculate consumer surplus type KPIs after a run?
Not recently, not the most recent model, but I believe that the previous version was definitely used for these kinds of calculations. And maybe Joel does something come to your mind?
Yeah, there was a cost-benefit tool built for the previous activity-based model used by SANDAG, and yeah, I think it was used in one of the plan updates, but ultimately, I think the planners didn't find it of enough value to update it for ActivitySim.
And if maybe I can tack on a little bit on that. I know there, particularly in some of the Australia participants, are very keen to use consumer surplus type measures in their project evaluation process. And it's something that we, in my former role in San Francisco, also used our activity-based model to support a whole range of different activities and project prioritizations. So there's certainly a lot of history in using ABM outputs in that way.
Okie doke. I think we've made it through the list. Thanks for this again packed Q&A session. And with that, I would like to switch to the second model that we're exploring today, the one by UrbanEcho and Eqasim. Grace and or Milos, can I ask to give your presentation, please?
Yeah, Grace will start, and I will.
Yes, I will share the first set of slides, and then Milos will bring the next one up. I would just share right away my screen. Yeah. Share. Can you see my screen? Can everybody see my screen?
Yes, we see it.
Oh, perfect. Thank you. So, hello everyone. I'm happy to be here. I am Grace Kagor. I'm currently the CEO of UrbanEcho, a spin-off from ETH Zurich, and we build digital twins, which are backed by agent-based, activity-based models for typically data-scarce regions. And I'll be sharing a bit about what we've been working on and the motivation, and also how we use an Eqasim as part of our pipeline for this. So basically our motivation really for this to focus especially on data scarce region is that the vast majority of future growth and development within urban areas is going to shift to emerging regions. And in these regions, we haven't been able to really adequately track or model or really understand the current data frame. So we can say like 90% of the rapid urbanization that is going to take place in the future is data invisible. And for us, we have seen also based on research that activity agent-based models are becoming the standard, especially within the transport modeling field. And for these regions, it's actually relevant because it is able to capture the local nuances, the local context, and you can also use it to model dynamic changes, which these regions typically have, from using mini buses and all of that, and bringing all of this within the agent-based or activity-based modeling context. But the issue is that the correct activity-based models, which you've also listened to, require really comprehensive data, like you need rich census data, you need detailed travel diaries, time use surveys, and a lot of these emerging economies don't have this kind of data. Some have some data, but the sample size is not enough. And then there's really this need to build some kind of inference engines without waiting for when to collect all of this data, because this is expensive. So that's our focus at UrbanEcho. Currently, a lot of research has been put into this over the years from ETH Zurich with the team, and also at UrbanEcho currently as well. And at UrbanEcho, our whole system is built as a modular stack, right? So we have different layers. We have the first layer, which is really going out there to find all different kind of data sources that exist in different regions, especially these emerging regions. We are using satellite-based densities, population densities that are provided by different entities, land use data, different kind of surveys, POMs, demographic health surveys that exist. And we collect all of that data, fuse it together, and we pass it into our synthesis engine. And I'm going to talk a little bit more about this later. And here is where we try to recreate this kind of like a digital twin of the urban system, where we generate the synthetic population that is as representative as possible, enrich it with different activities, also assign locations for all these different activities. And all of these take place within the synthesis engine. And from there, we feed, because we also want to capture a behavioral aspect within the digital twin framework. We create a scenario from all of this, feed it into an agent-based modeling framework, activity-based. Also, here we use MATSim. We are open to using any simulation framework, but because MATSim we've used for a long time, we're using it. And then the output of MATSim is fed into a knowledge graph that goes into the cloud. There's a whole cloud infrastructure that then provides all of these results as a user interface for users with a cognitive architecture that users can ask natural language questions and also use this baseline model to create their own scenarios and ask different kind of questions, basically. And now the main thing for us in this discussion is to focus on the synthesis engine, which is where we are able to use Eqasim. But before talking about Eqasim, because I'm not the one talking about Eqasim today, I'll talk a little bit more about this synthesis engine and why we're also using Eqasim for it. So synthetic populations is the first aspect. We want to generate synthetic population. And the key question for us is, how can we make our synthetic population statistically representative without having like full sensors or detailed demographic surveys? And here we are looking at using Bayesian networks. There's research in this direction compared to using like, if you want to avoid issues, having some more demographic surveys where you have zero cell issues and all of that from IPU, iterate proportional fitting or updating. We chose Bayesian networks because you can actually learn the different household structures and relationships and increase the pool before you do combine it with any census detail that we have. So we'll be doing that. Basically, you have this network, you want to do it at a household level. So I'm showing a graph for like a core household for city of Bogota, for example, with children. And then you want to really have marginal distributions that kind of fit with census data that is given or a sample survey that is given. Basically, this is the main part. And we're constantly working on these to generalize these to different regions. And the second thing is you have this base population that has social, the age, gender, and all of that. You need to enrich it with different activities. And typically there's usually no travel diaries. Some regions have, some don't have. So I'm working together with a colleague currently at Northwestern Janody. We've been looking at using geospatial embeddings to identify sister regions and then applying transfer learning for these to predict activity patterns based on these sister regions. This is something we've been working on. We just threw a short paper on how we used it to predict work durations using just Google's geospatial foundational models. And for us, we want to see how we can really use this to predict activity change and so on and so forth. So it's a work in progress. If you're interested, you can talk to me much more deeply later. But it goes to show that we can actually predict activity change for regions that don't have using the behavioral aspect of spatial geospatial embeddings as well. And let's say we are able to enrich with activity chains. You need to assign locations to these activity chains. And there is a few research in this direction. I want to make a shout out to Color and also Eqasim as well, because Eqasim has a standard location assignment model, which you can update as well. And to talk about some of the aspects is that where we've been working on is you have OpenStreetMap, which is very detailed, but for certain regions, we've try to plot how like building locations for homes, they are representing OpenStreetMap, for example. And we discovered that it's not as representative when you go to certain regions. For example, if we go to Kenya, certain regions in Kenya are not properly represented. And then we discovered that there is a flood of data out there right now. Google building footprints, Microsoft building footprints, and all of these are integrated to Overture maps, which we're then pulling in to have representing POIs. And then based on some of the research I did during my PhD and also other research I would say, we start to use this kind of donut-based sampling to do this primary and secondary activity location assignments that have been validated over time. So there are models that exist to work with whatever data that we can extend to this region to actually create activity-based and agent-based models. So that's my message for everyone. And how to do that, to create this whole synthesis engine, and the scenario that you can then feed into your activity-based model or your agent-based model, we are using Eqasim. And I'm not the one to tell you about Eqasim, but I'm going to tell you from my experience why we chose Eqasim. But from the fact that I'm from ETH where it was born, it's a Python-based pipeline. You have seamless integration. We can quickly develop. So all our dev team, they quickly come in, they rapidly learn how to use it, and they go just within a week, really, and they build on top of it. And it's very modular. We're able to plug in our Bayesian network models or our location assignment models quite easily. So any custom model you want to run, you just plug it in. And the good thing is then you have an output that you can immediately plug into MATSim. You would have to adapt it for like Polaris because we also want to test other agent activity-based models also as well. And which means it's very scalable. And from this, I'll give the floor to Miloš to talk about Eqasim, how you can use it and see how easy it is to use. Miloš, over to you.
Thank you, Grace, very much. Yeah, I think you can see my my screen. Okay, let me get rid of this. Yeah, so what I want to talk about is a little bit about the background of Eqasim and its basic structure and why does it make it so easy to adjust and to adapt to other regions. Why did we decide actually to build a new tool, to develop something new, to something maybe different than what was already there? So basically, somewhere in 2018, we were asked by Airbus Urban Air Mobility to develop a multi-agent based models for various countries around the world. And in a very short period of time. So we needed to find a way how to do this, and they had some very specific requirements, and some of those were that this tool needs to be open source. It needs to rely completely on open data, so we cannot rely on proprietary data. So we had to ensure that we can rely on these in each of these different countries on generally available data sets. It needs to be transferable in order to be applied to these, not only to these regions that we were asked to build this model, but also to other regions. Needed to be reproducible, meaning that anybody else can also reproduce exactly the same model outcomes as we have, and needs to be understood. Okay, so it needs to be easily understood for this model to in the end be also trustworthy and accessible, easy to use. And that is why Eqasim came to life somewhere in 2018. It was first developed for Paris, not for Switzerland, but it was first developed for Paris. That is why the main reference or methodological reference for this tool is actually around the data that is available in the region around Paris. During that project, it was also applied to Switzerland, Sao Paulo, California, and Jakarta. Since then, it was used and it is used all over France, in Canada, Germany, UK, and many other places. It is Python-based, so it seems everybody loves Python, so we love Python as well. It's also open source, and what is important, it's very modular, and basically you can easily integrate the outputs of this model with MATSim in the first place, but also potentially with other agent-based models. What is important is that it uses the SynPP Python library, which enables basically creation, organization, and managing of different stages within this pipeline that are responsible for different parts of model development. What it also then enables is easy replacement of different stages with a different kind of a model. The general overview of the pipeline you can see on the figure below. So basically we start from the raw data, generally available open data. So this is the basic idea. I'm going to talk about the basic idea here and not about many other complex modules or stages that we have developed along the way. Then we have the pipeline that is basically processing this raw data using straightforward statistical methods, and then building the basically an activity-based, let's say, synthetic population that has activity chains that can be then plugged into an agent-based model. So I want to talk about 4 basic stages. These are population synthesis, statistical matching, mandatory activity location assignment, and secondary activity location assignment. So these are the basic building blocks. Each of these can be easily replaced, but also can be enriched with additional, more complex or probabilistic models. But I want to talk about the basic idea and where this comes all from. So Eqasim as a tool is not responsible for population synthesis, and this is why also Grace has to deal with this problem, especially because she has an issue in data scarce regions in developing countries. So basically, Eqasim does not do this for you. We have some examples using the IPF, IPU, Bayesian networks, as well as what like Grace is using, but this is not something the responsibility of this pipeline. So this pipeline expects that you will have some kind of a synthetic population that you will pass it on through the pipeline. Then basically what we have as the result of this first basically kind of synthetic population part, where we still have to process the data in order to structure it in a way that Eqasim pipeline understands it. Okay, so this is typically, age, gender, marital status, employment status, driving license, number of cars, number of bikes, income, so on and so forth, home location, household structure, and so on. So this is basically somehow has to come from somewhere. Of course, we have been also developing mobility tool ownership models and so on, but this is not something the main idea behind the Eqasim. In the next stage of this pipeline, we attach activity patterns to each individual in the synthetic population. We use statistical matching, also called hot tag matching, where we try to find in the synthetic population, so we take an individual from the synthetic population and we try to find similar observations in the travel survey. Then we sample from these similar observations based on the weights that are associated to each of these samples and attach an activity chain to each synthetic individual. So basically this allows us to have then a representative activity patterns across the population that we are modeling. If some of the variables are missing in the synthetic population but are available in the travel survey, they can be imputed together with the activity chain. So basically what we have in the end, after this stage is over, we have an activity schedule. So basically we know the sequence of the activities, we know the type of the activities, and we know the length and start times of these activities. What we do not know the modes that are connecting these activities, and we do not know the location of any of the activities except the home location. Then we go to the next step. And as I said before, we are using straightforward statistical methods here. Okay, these are not econometric methods. So these are basically very straightforward statistical methods in order to create a representative population and their activity patterns for the region. In this stage, we typically use commuting matrices. These are available almost everywhere. We use these commuting matrices to probabilistically assign to every employed person a workplace location, ensuring that commuting matrices are respected as a first priority. together with the commuting distance that is matched during the statistical matching as a second priority. We can also use the mode, the main commute mode of each person as an additional variable. What we also here ensure is that every workplace location has the correct number of employees, obviously if that data is available. This data is not always available, especially if you rely completely on open data sets. At this moment, what we have additionally the location, the work location, we have the activity patterns, but we do not still have the location of secondary activities. And this is done in the last stage. This is a methodology that was published by Sebastian Hurl and Kai Axhausen in 2023. And it basically aims to find the locations of secondary activities in order to match the distributions that are observed in the travel survey. Okay. So a brief overview of this algorithm is available on the right. So basically, it doesn't really matter how many discretionary or secondary activities you have in your chain. This algorithm basically finds these locations in order to match these distances, also by the mode that the person is likely to use for these kind of distances, given the mobility tools that this person actually has available. What we finally have, we have the entire synthetic population, their activity patterns, their locations, starting times, and durations. What we do not have is the mode of travel and the route. This is what we use in our case, MATSim, where we do the assignment and then we do explore the different policies and their outcomes. So this was the basic thing. A much more complicated thing can look something like this. And this is something how it looks like in Switzerland. Especially here, we do quite a lot to ensure a complete automation of this process, where we do have to estimate models. We do have to estimate mode choice models. We do have to estimate route choice parameters. And we do this in an automated way, okay? So basically, one that obtains this model can run this from start to end in a seamless way. Now, Grace, I think you have a few words, and then I will wrap it up.
Yes, so basically, one of the key themes to talk about is the challenges of working with the different data, especially if we're building these activity-based, agent-based models, which is our goal to build all of these for all the cities in the world, regardless of wherever the city is, which can be a basis for a digital twin model. One of the key issues we're working on right now is really being able to validate these models, especially in data poor environment. We're looking at, for example, we said we're looking at these geospatial embeddings. We're looking at also how we can use these kind of inferences or transfer learning as a way to also validate these models. Another thing is, while we are using Bayesian networks, we also have to be careful that we're not overfitting to the different survey data that we have compared to using aggregate census data. And also, we have to also check whether we have the right optimal complexity level. And these are things that we are currently working on to improve how we can actually generate this model. And at some point, we would have these out for people to use as well. And one of the things we do consider is that in the population pipeline itself, especially when you're generating synthetic population, or you have to consider and adapt to the local context. And we are currently trying to see whether there is a way to automate depending on the region or different regions, so you don't have to do a lot of heavy lifting. For a typical example I always share with people is that some regions, you have the household model, the household structure, and then you you add in another region, and then you find out that your household structure just had one husband and one wife, and then the next one, when you put another region, you have one husband and 5 wives, and the whole system breaks. So, these are some of the challenges, but really having a pipeline where you can easily treat this error works, and you can flow from one step to another. So this has helped us to move forward. And this is the direction in our research, to kind of automate and generalize it, and also add some of these models as well to the Eqasim pipeline so people can use them for data scarce regions as well. So, yeah.
Yeah, maybe for the end, if you want to try out the Eqasim approach, I would advise or suggest that you use the French implementation. It is completely based on open data. It is amazing in France how much open data there is. You can build a model for any region in France. Doesn't matter small or large. You can do it, and you can do it in a few hours. Okay.
Yes.
So basically, from start, gathering the data, running the model, generating the output, and you can even run this model directly within MATSim. There is a full documentation for Ile-de-France. It is available step by step. What you need to do. It is very lightweight, very minimal environment that you need to have. For those that are interested in methodology behind each of these different steps, you can take a look at the publication. We also organize yearly workshops. One was just 2 days ago, so you missed it, but good news is that we do this every year. And if you're interested in developments or kind of new challenges that we are trying to solve, you're very welcome to also join our yearly workshops, either in person or online. With that, we would like to thank you all for listening in. And if you have any questions, please feel free to ask.
Perfect. Many thanks, Grace and Milos, for the presentation and for the perfect timekeeping as well, just as the previous presenters. So we have enough time for questions. Grace was already very busy answering questions in the chat, but so we'll start with the questions that have not been answered yet. A recurring theme in the presentation was how this can help build models in data scarce environments, whereas much of the previous research was done in data rich countries. That raises the question, even if you do not have the perfect survey or the wonderful time use survey in a certain country, cell phones are everywhere. You have not spoken about how to add cell phone data or let's say passive data collection in your framework. Can you please share a little bit about that?
I guess, Grace, this is for you.
Okay, yes. So this is work in progress because we are trying to work on a pilot where we gather these different kind of data sources. For us, it's important to build with existing easily accessible data that we can get, and also from the different government. The reason why we haven't started to push towards cell phone data is because for these different countries, there are a lot of restrictions in getting them. But from ETH, there's a thesis on how to use OD data to cell phone data to generate agent-based model. And for us, when we get to that stage, we plan to replicate that thesis and add it to our own framework. So this is already done. Temo is, if anybody is interested, I can put the link to this thesis in there. And if you're interested in coming to add it to our framework, please reach out to me, and I would like to have you as well. Yeah.
2 questions, thank you. 2 questions deal with the spectrum of public availability of data. Public available period is the extreme case. You can just take it. It's open government data, for example. Okay. The other extreme is the agency that is trying to build a model for themselves has non-public data that is more detailed or somehow more accurate than the publicly available data, and they want to use that instead or in addition to the data that's normally used in Eqasim. How can they do that? You answered already with a yes, and that it's possible to include that in a pipeline, but maybe because it's so relevant, can you add a few words on that? And then I would like to continue it with the question, what about the gray area in between those two extremes? Census data are often, let's say, semi-public. You have to at least to apply and register, or at least prove that you are going to use it for a legitimate case. If I don't have access to that kind of census data, but I want to build an Eqasim model, what would Eqasim do in such a case?
Okay.
Okay.
It's a very good questions. We have dealt with many different regions. So we do have experience in kind of the level of detail that these public data sets have, right? And you really find things all over the place. You even find public data that is very, very, very detailed. For instance, in Sao Paulo, they had census data that was, I think 40% of the population was contained in this data set. Okay. It was very, very, very little aggregated. Okay. But then you have other places where you have very little public data. And Switzerland is actually one of those countries. So Switzerland model is almost entirely based on proprietary data, the ones that are supplied by the agencies. We did some work to evaluate, for instance, how much anonymization of the data is impacting the quality of the models. And we did that with to evaluate the quality of mode choice models. And we actually found that in the cases in Sao Paulo, this data is anonymized. You can get different versions. You can have anonymized or non-anonymized. The same is in for some regions in France, if you have a regional travel survey. And we actually found that this anonymization does not have a very substantial impact on the model outcomes. So already this anonymized data in terms of travel surveys is already quite useful. So we have dealt with different situations, and I think by now we have a lot of these different kind of code options that you can apply for different kinds of situations. For instance, we also used PUMS data and the marginal distributions in California. Then we also had some kind of, let's say, 20% sample data of census sample data in France that then we expand using different methods, or we have completely entire data set in Switzerland for every individual, but then this is kind of, you have to sign a contract and you have to show why are you using this data and so on. We have explored these different options. I would say that everything is possible. The level of detail one has access to, the better the model is going to be. But it's not always so important to have really the most disaggregated data. But I think extremes are not really ideal. If all the data is proprietary, then the models we are building are not open at all. And on the other hand, if everything is so aggregated, then the model quality again is not that good. So there needs to be a balance between the two. And this is what, for instance, in France, I have to mention this case as well. It is like that. You really have a balance, and you can build an open data model anytime you, in a few hours.
Thank you. Given the focus of the presentation, most questions revolve around data sources and how to use data for building the model.
I love
Not
data.
a surprise.
I love data.
Yeah, sure. I do see one question that deals more with the choice models inside.
Sure.
In that case, probably the UrbanEcho model built from that pipeline. And that's about balancing number of work activities against the employment size of a zone, or at least of a region in the model. How do you balance that, and how do you deal with working from home, for example, as a recent trend?
So I would throw this question to Milos also, because they've been working on working from home and integrating it into the Switzerland pipeline and done a lot of work on that. So he's better positioned to answer that question richly.
So actually, what I can tell you is that we are currently building two models, regional models in Switzerland, and we do use then additional data sources, and especially working from home is an important topic. The last useful national survey that we have is from 2015. So we have to rely on other sources in order to be able to model the behavior of today. So we rely on other data sources that can tell us a little bit more on how frequently people work from home, which days of the week. And we basically currently building a Bayesian model in order to assign to every individual would they work from home? Can they actually work from home? Because different jobs restrict you, right? And then how often, and then on which days of the week would you do this? But this is again proprietary data that we rely on, and then we apply to these specific regions in Switzerland. When the new travel survey comes out, 2027, they're now collecting the data. We will have from the travel survey where we can actually do this directly from there. But yeah, this is 2 more years to go.
Yeah. Just to add to that, because from our side, we're always hunting for different data and seeing how we can do some transfer learning to transfer most of this data. Also at the Institute, Transfer Planning Institute, there was a time use survey, detailed time use survey that was taken, which also includes elements from working from home. And if someone wants to use that data, assuming that the behavior in Switzerland is similar to the behavior in the region you want to model, you can also use that data source itself. So for us, if we find a region that has similar geospatial behavior with Switzerland, we would definitely then use that data that is available. And I think it's open because it's under the ETH, it's open data. Milos, you have to confirm with me whether the time use survey is open source data.
No, it's not open, but it's you apply and I give you permission to use.
Yeah, so you can get it for scientific research, and then you can use it to test your models. Just to focus on the work employment and how to ensure that you have that. So we've been working on from the Sustainable Urban Transition Lab at ETH. We've been working on Seville and Hanover, building like a data stream model for those two regions. And even though you would assume that there is detailed data, we still find that you still need to estimate like the work, the number of people working or the employment distribution, which is not usually released or out there. And we basically make estimates from reports or do some statistical matching to ensure that the distribution that we come up with really match the employment. So these are things the beauty of the pipeline is, the final result. Now, you just need to adapt or enrich it based on what you want to have. So if you need work from home, you add a work from home variable or attributes at the end of it. I hope that answers the question on this work and employment.
Sure. Thank you very much. And I don't see any additional methods. No questions in the chat. So I'd like to wrap it up here as well. Thank you again for this very interesting presentation and another flood of information in the Q&A session. Very impressive and very useful, I'm sure. I have one suggestion to all presenters. We've been getting questions about contact. How can we get in touch? And in some cases, I think Grace put something into the chat. I will ask for the slides to make them available via the EAABM website. And before you send them to me, maybe edit in this information into the slides as well, if you haven't done so already, because the chat will not be visible to people who will later review the recording, right? So that will give them another way to find the contact information and get in touch with you. Could be useful. Which leaves a last point for me. I think Alex is not on the call, but Peter Jones, the president of EAABM, is, I presume. So if I may call on you, Peter, if you want to end the session with a few words on EAABM and how to get in touch with us, then
okay, thank you very much.
Very welcome to do that.
Thanks very much indeed, Klaus, and thank you for everybody being on the call. It's been a really valuable afternoon. I think it's the whole purpose of EAABM really, to have a chance of bringing professionals together to get into the detail of what's going on and to reach people's understanding. And alongside people on software development application, we're also trying to engage with decision makers, people in academia and elsewhere involved in more fundamental research and also in teaching and making people more aware of what's available and what can be done in the future. So we have a meeting in the next couple of weeks to plan our 2026 programme. And we've got 4 streams altogether. We've got the one that Klaus is leading on software. We've got one on more basic research. We've got one on sort of policy and applications in that sense. And we've got one on teaching and learning. So we're hoping to have a more complete programme next year, and then at least 1 or 2 international conferences to host a session on a particular theme. So we sort of welcome you to keep in touch through the website and encourage other people to join. And I wish it's been a busy year for all of us, I'm sure. So I hope you get a bit of relaxing time over Christmas and New Year, and looking forward to see you at events in the future. Thank you very much indeed. Anything else, Klaus, you'd like to say?
No. Thank you. Thank you to all the presenters. Thank you to the audience with all those questions that came in and added spice to the session. Thanks, and have a great rest of the year and peaceful Christmas. Bye-bye.
Thank you all very much. Goodbye. Bye.
Thank you, everybody.
Okay.
Have a